Now, I spent a little more time on reliability than I'd planned to, but I want you to feel comfortable with it. I want you to feel comfortable with the concept of the standard error of measurement, because it is an important concept. As we start interpreting test data, it makes a lot more sense to say, hey, I believe that instead of saying Johnny got a 96 on a test, I can say, well, Johnny scored somewhere between, let's say, 86 and 106. There's a 95% chance, let's say the standard error is 5 points. There would be a 95% chance that Johnny scored between 86 and 106. We can say with reasonable accuracy that Johnny's in the average range. And it makes sometimes a lot more sense to give a range than it does to give a specific score, because we all know that there are reasons why that specific score may in fact not represent what we really, or what Johnny or Billy or Mary really knows, but it may represent rather a fluke. And we can start looking and say, well, maybe he's a little above average, maybe he's a little more below average, but clearly he's in the average range. Okay. Now we want to go to the concept of validity. And if you've seen your Module 4, there are some pretty good explanations of validity, but I would like to reinforce those a little bit. Basically, when we're talking about validity, we're asking the question, how well does the test measure something? Now, if the test is not valid, then why in the world would we want to use it? Because validity always implies that there is an interpretation being put upon the test. When we say it's valid, we say it's useful for some particular purpose. And we're going to talk about those purposes. Actually, tests can be used for several different purposes. And if it is used for several different purposes, it may in fact have several different validity coefficients. Or we may look at validity in a number of different ways. Let's take a look at a couple of the validities that were talked about in the module. Content validity is looking at how well does the test really sample the things we've tried to teach. And then it talks about face validity as being sort of a part of content validity. Actually, face validity is not true validity. But the reality is, if the test doesn't really make sense, people are not going to take it seriously. Therefore, it may affect the validity of the test. So while face validity is not true validity, it's an important concept. And if you say you're going to give a reading test, you probably ought to give a reading test, and it probably ought not to be computational issues. So let's take a look at that. And that does impinge upon content validity. Now, basically, we ask the question, is this test measuring the kinds of things we're trying to teach? I'm going to give you an example. Suppose I put on the test this question. The teacher of this course spells his name E-L-D-R-I-D-G-E, E-L-D-R-I-D-C-H, E-L-D-R-E-D-G-E, or E-L-D-R-I-C-H. Now, it might be good for my ego if you know how to spell my name. But in reality, is it really related to the content of what we're doing in this course? And the answer is no. Now, you may insult me if you don't know how to spell my name, but it really is not related. And I have had questions just like that on tests. In fact, university professors are notorious for asking irrelevant questions on tests which are used in various classes. I'm going to give you one that was used on me when I was a master's candidate in rehab, and that was 150 years ago or so. Actually, it was the early 1960s. Mary Schweitzer had been the Commissioner of Rehabilitation for years and years and years, and stayed on in that position for many years through several administrations. She was kind of considered the mother of rehab. And so one of the questions on my midterm test was, the Commissioner of Rehabilitation is Mary Schweitzer, true or false? Well, I marked it true. Now, I know that Schweitzer was spelled S-W-I-T-Z-E-R, and I just assumed that the professor had made a typographical error, and that was my error, because what he was really testing was spelling. He was not testing my content knowledge, but my spelling. That is not an atypical question, but it is not a fair question if you're really trying to get at the content of the material you're trying to teach. Now, I could ask that question today of my students, and I could say the Commissioner of Rehabilitation is Frederick Schroeder, and I could probably spell Schroeder 6 different ways, and I'm not even sure I would get it right without having his name spelled right before me. Is it important to know how to spell his name? Well, it is if I'm writing Fred Schroeder. It probably is if I'm publishing an article and I'm quoting Fred Schroeder. But in terms of my ability to regurgitate the spelling of Schroeder on a test is probably relatively unimportant. Now, we can all find examples in most of our undergraduate and many of our graduate classes about obtuse questions, which really have little to do with the content of what we say we're trying to teach. Now, to be truly valid, the test items not only should represent the content, but they should be in about the same percentage as the amount of time or effort that is spent on that particular content. For instance, in this class, let's say I spent 10% of my time on general testing, 10% on history, 10% on reliability, 10% on general statistics, and 10% on validity. That's for the first half of the class. Let's say that I did each class session and I spent that much time. Then my examination should reflect that, and I should have about 10% of my questions on general testing, about 10% on the history, about 10% on statistics, about 10% on reliability, and about 10% on validity. Well, I should have about 20% on each of those because I've got 5 areas there. But they should be equally divided. Those questions should be equally divided among those respective areas. Now, I can assure you I did not go to that much difficulty or that much trouble when I made up the test. I just made up test items that I thought nobody could pass. And then, no, not really. I just made up test items which I thought covered the content that I was trying to teach, but I admit I did not go through that. 20% in history, 20% on this, 20% on that. Rather, I asked questions which I thought would help us more fully understand the concepts that we've been talking about. Now, content validity is found out by really examining the test. You have to do a very comprehensive examination of the test. You look at the items and you try to evaluate the items to determine whether or not the items are representative of the material which is being taught. Its greatest use, of course, is in achievement tests. Now, a course examination should, in effect, be a form of an achievement test. Now, there may be other purposes for a test. For instance, if I have a professional seminar, I may not be looking so much at achievement as I am thought process and ability to work through a problem. In other words, I might have different reasons for giving a different kind of a test. But in a content class especially, the material which we test is a form of an achievement test. So I would expect that in this class where there's a lot of content, you would have a form of an achievement test. And that's what, hopefully, we have done for you. Now, there are other kinds of validity as well. We've talked about content validity, and face validity certainly is part of that, but like I said, it's not a true validity. But face validity says, does the test look like it makes sense? And that is an important consideration. Now we're going to get into 2 kinds of validity. Sometimes they're called the same thing, and they are very similar. And in fact, sometimes the only thing that separates the two is a short time interval. These are called predictive and concurrent validities. Now, predictive validity is asking the question, does this test predict some important future behavior? Concurrent validity is asking, does the test give me an indication of some present performance or behavior? Let's spend a little time on predictive validity. And I know there's a fairly good explanation in your module, but let's talk about it just a little bit, because I think there are a couple of concepts that at least I hope you get down. We get predictive validity by basically giving a test and then sometime later getting a measure of a criterion of performance. And there's a space involved there. There's a time period involved between the administration of the two instruments. And then I run a correlation between the two, and I say, is our test, does it correlate relatively well with our criterion? And if so, then I can say that I can use the test to predict some future performance. Now, we do this a lot. Colleges and universities used to do this routinely. They would take your high school grades, and they would take, let's say, the ACT or the SAT or the College Entrance Examination Board, any one of a number of tests. And they would combine those two together and would come up with a prediction of how well you would do in college. And that's a fairly useful tool. But once again, we recognize that we don't always make perfect predictions. In fact, we never make perfect predictions. But we get at it that particular way. Now, it is expressed as a correlation coefficient. Now, this criterion related means it's related to some criterion outside of the examination itself. So we always have two measures. When we're doing any kind of a correlational study or any kind of a prediction study, we have two measures. Now, sometimes that can be very helpful, and sometimes it's not particularly helpful. And sometimes we might want to do a little better job of predicting for some kinds of occupations. For instance, I would hope that if we have a pretty good measure which selects out individuals who are going to be successful in medical school, that we do a pretty good job, because if I have to go in for surgery, I certainly don't want someone who's been predicted to fail. Similarly, if I'm going to be flying from here to Washington, D.C. on a fairly regular basis, I want a pilot who's been predicted to succeed. I don't want one who's been predicted to fail. The consequences, obviously, are pretty severe in those cases. We do this all the time. As you know, you have to take an entrance test, and that's what it is, to get into graduate school. We say you either take the graduate record examination or the Miller Analogies test. Why? Well, we use that in combination with your undergraduate GPA to predict a level of success in graduate school. I have a daughter who's taking the medical school admission test on Saturday of this next week. So she's been highly anxious about this. She's been studying 3 hours a day for many weeks, and she's hoping to get a high enough score to be admitted to a medical school. It's a lot of work. There's a lot of pressure. There are courses that are taught. She paid $800 to take a preparatory course to prepare for this examination. I have a son-in-law who's an attorney. He paid several $100s to take a preparatory course for the law school admissions test before he was admitted to law school. So you see, we do this all the time. Now, are we any good at it? Are we any good at predicting? Well, we're going to get into that in just a minute. If we take a look at kind of a sample here, we can see that we plot the test on one side with the criterion measure on the other side, and we get these little X's, and these little X's indicate the score that the person got on the test and the score the person got on the criterion measure. Because before we can do any predictions, we have to run a group of people through, get the correlation, and then determine whether or not it's possible to predict for that individual, or whether the test is very predictive for that individual. Now, when we do that, we have to make some identification of some point which we call success and failure. And that's not necessarily an easy thing to do, but we usually find some measure, some criterion measure, which we use. And then usually what we would do is we'd take our line of best fit, and then that sort of becomes our cutoff point. And we know that we're going to get some people who scored high, or who scored low, but would have been successful. We know we're going to get some who scored relatively high on the test, but who would fail. We know we're going to get a lot of people who scored low and who would fail. We know we're going to get people who scored high and who would succeed. So we get these kinds of measures. Now, how important is that measure might be determined by what we're looking at. Let's take a look at this example here, and I've tried to draw some figures in there to help you kind of look at this. But these little X's represent, of course, my test and my criterion measure. Somehow I've been able to identify a point here which says above this point these individuals are going to be successful, below this point they are failures. Now, when I'm testing airline pilots and physicians, I might be very interested in having a cutoff score up here, you see, where I have absolutely no failures. I have no failures. People who scored up in here, see, were all successes. So I might, in those cases, I might say, look, I can't chance a failure. So I'm going to raise my cutoff score way up here. Maybe I have another situation where I have just limited training spots. I can handle a failure or two, but not many. Maybe I could drop my cutoff score down here a little bit, where I'm going to take a chance on one or two people, but I'm going to get more people who are likely to be successful. Maybe on the other hand, it doesn't hurt if I have a few failures. I want to be sure to get everybody who's likely to succeed, and so I might drop that score down here, and then I would say, look, all of these people are likely to succeed. Below this score, everybody failed. Some people above that score also failed, but below that score, everybody failed. Below that point, everybody failed. So I can eliminate them from competition. But you see, I'm always going to have some in here, and I'm always going to have some in here. These are individuals who are predicted to succeed who would fail, and these are individuals who would be predicted to fail who will succeed. And where we put this line may in fact be entirely dependent upon how serious our occupation is that we're putting that person into, or how serious the decision is that we're making about that individual. Does it involve life and death situations? And if it does, we may be inclined to move way up there and just take the very best candidates. Now, I ask the question, how well do we succeed in predicting? Well, if you read all the literature, it says we don't do a very good job. But I'm going to try and show you why. If we have our test here and we have our criterion measure here, these little X's once again represent all of the people, and this elliptical form that I've drawn here is kind of an indication that we have a high positive relationship. And that's true. If we were looking at everybody in the universe, we would have a pretty good predictor. And sometimes if you want to look at this in this manner, I think we did this a little bit once before, but let's just take a look. If we have our x's like this, remember, that was a perfect predictor, wasn't it? If we have one that looks fairly elliptical, that's a high positive predictor. If we have one that looks like this, that looks like no relationship. In other words, the closer that is to a circle, the closer this is to a circle, the less likely we are to have a very good predictor. The more it looks like this ellipse, or the closer it approaches a straight line, the greater the chance that we have an instrument which is a fairly good predictor. But now look what happens. When we predict for graduate school, who do we admit? Only those with grade points above 3.0 and those who have relatively high Miller analogy scores. So what are we doing? If we were taking everybody, the graduate record exam would be a good predictor, and we could identify a cutoff score. And in fact, that's really what was done originally. But now what happens? Now we restrict it only to those people who have graduated from college, who have relatively high GPA, and who have relatively good scores. Now you see, what happens is we have much more a circle there than we do an ellipse, don't we? In other words, we have done what is called restricted the range. And restricting the range does affect the validity coefficient. So sometimes we might artificially, and that's what we've done here, we might artificially lower our validity coefficient. So if we were looking at the validity across everybody, if we were giving everybody the GRE, and we were predicting success in graduate school, or predicting grades in graduate school, we would get something that looks like this, and we might have a prediction coefficient of around 0.7. But here, our predictions go down to about 0.3 because we've cut off part of our range. And so our validity coefficients for graduate school aren't very good. They really only predict about 0.3. 0.3 times 0.3 is 0.9. About 9% of what goes into grades in graduate school is accounted for by our tests. Why? Because we've cut off much of this information. But that's an artifact. Now, should we restrict enrollment in graduate school? That's always a question that's been asked. I've had students come up to me and they've said, you know, I only have a 2.0 and I've got a 19 on the Miller analogies, and I've got 200 verbal and 200 quantitative, but I really know I'm smarter than that, and I'd really like to get into graduate school. Won't you just let me in to have a try? And it's a tough call. It's a really tough call, because sometimes I believe them. Sometimes I believe they've goofed off, and they're paying royally now as they want to get into graduate school. I think they're very bright people, but how do I make that decision? Well, in the absence of substantial data, it's very difficult to make a decision. Why? Well, we have limited funds. We have limited faculty. We have time constraints on the faculty. The university has limited resources. This university has grown about 50% in the last 5 years. We have, when I first came to Utah State University 4.5 years ago, about 12,000 students. Now we have nearly 18,000 on campus. How do you accommodate for those? Because the faculty hasn't increased 50%, probably increased less than 10%. You see, we have tremendous pressures on us. And using that information then, do we have a right to restrict admission to graduate school? Well, most graduate schools think we do. And these are not easy decisions. And I don't know if there's a good answer. I don't think there's a cut and dried answer. I don't think there's a perfect answer. But nevertheless, we use that data, and that's why it's being used. So if some of you have tried to get in and you can't quite make it, I've tried to give you a few suggestions as to what you can do, but the reality is we're getting more and more pressures on us with fewer and fewer resources. Well, now, that's predictive validity. Let's take a look now at concurrent validity. And concurrent validity is saying, now, does this test measure some important current behavior or trait? For example, can I develop a test which will assess the extent of brain damage in the case of someone who's had a traumatic brain injury? That would be very important information. If I could figure out, you see, based upon one test, that this person had certain levels of traumatic brain injury, could I then help that person by either accommodating or changing the program of studies or something like that? And that's always a goal that we would like to do. Let's take a look at my Eldridge Intelligence test. Suppose I could make an Eldridge Intelligence test that costs $1 to administer, and I can give it to 500 people at once. And let's say it had a perfect correlation with a Wechsler Adult Intelligence Scale. Well, shucks, I could put Wechsler out of business, and I'd be the millionaire. And you see, but that's not been done. I haven't been able to do that. I have not been successful in developing an Eldridge Intelligence test which has a perfect correlation with the WAIS and which can be given for just $1 a piece. You see, if you do an individual test of intelligence, it's going to cost you a couple of $100 as a general rule. That's a fairly typical fee, maybe $300. Can you afford that? Well, maybe you can't. So can I get a reasonable substitute? Can I get a reasonable indicator? And this is what schools have done. They've moved to group tests to help us identify those individuals for whom an individual test should be given. Because there is a relatively strong correlation between many of these group-administered tests and individual tests. And so we can use the group test as a less expensive approximation for the kinds of information we're trying to glean in a more expensive test. Clearly, the cheaper substitutes are not as good as the more extensive tests. Now, as we talk about concurrent validity then, we really are interested sometimes in the here and now. And yet the correlation is between a measurement today and a measurement, two measurements taken basically at the same time, so there's no time lapse in between. But it still is a validity coefficient. It still ranges in size from 0 to 1. And validity coefficients, by the way, can be positive or negative. Remember, reliability coefficients can only be positive. But validity coefficients can be positive or negative. But a validity coefficient is a correlation of two different measures given to the same set of people. When we talk about validity coefficients, I'm talking about now predictive and concurrent validity. Once again, we want to ask the question, how much faith can I put in that given score? Remember when we did the reliability, we talked about the standard error of what? The standard error of measurement. That gives you my standard deviation if I were to take the test 1,000 times. Now, with a validity coefficient, we talk, instead of a standard error of measurement, we talk about a standard error of estimate. A standard error of estimate is how much faith can I put in that given predicted score? Now, let me give an illustration. I happen to know that when we predict freshman GPA using grades and all of the other data that we can, and by the way, you can add things together and get multiple correlations, and that's explained in the videotape. I know that the standard error of measurement of that prediction is about 0.6 of a point. Now, what is 0.6 of a point? Remember the grade 4.0, there are 4 points on the scale. Well, it goes from 0, 1, 2, 3, 4. So you really have 5 points on the scale, don't you? Because you start at 0. This would be an F, a D, a C, a B, and an A. I know that if you're predicted to get a grade point average of 3.2, that the standard error is 0.6 of a point, the standard error of estimate. That means that I can expect a grade point somewhere between 2.6 and 3.2 plus 0.6, 3.8. Now I can, 2.6 is a B minus, and 3.8 is an A. So there still is a little bit of an error in there, isn't there? If you want to look at it in this manner, this is kind of what we look at. We say, now, look, if I could, for each of these, if I could draw a little normal curve around there and take the standard deviation of that curve, that standard deviation would be the standard error of estimate. And that would tell me how much variability I can expect for this test score, how much variability can I expect, the mean of which would be the predicted score. The standard error of estimate would tell me how much variability I can expect in that predicted score. Now, that assumes, of course, the same distribution, or that each of these curves looks the same all along here. And I'm going to give you a 2-bit word or a $1 word for a 2-bit class or something. We call that homoscedasticity. We make an assumption. Isn't that a big word? It's a fun word to say. Now try to spell it, okay? Homoscedasticity, Homoscedasticity. What that says is the distributions look the same along here. That's all it means. And that's an assumption we make whenever we use the standard error of estimate. And the reason that's important is you could get a distribution which looks like this. You see? And then as you get up, what happens is and you get a distribution which looks like, let's do it this way. You see, it doesn't look the same at all. You've got a much bigger distribution here than you've got here, where you've got a very narrow distribution. If you've got that kind of a situation, then it's not a very good idea to start using the standard error of estimate. Once again, we want to take a look at reliability and validity and the relationship to one another. Remember, if you have a reliable test, it doesn't necessarily mean it's any good. If you have a valid test, it must first be reliable. And look at that target example in your videotape, because that helps you to understand that you can have reliability without validity, but it's impossible to have a valid instrument unless it's first reliable.